Hey guys, this is CHEMPLIFIED and today we will talk about chemical properties of aldehydes and ketones. This is part 6 of chemical properties of aldehydes and ketones. In this particular video, we will discuss the oxidation and reduction reactions of aldehydes and ketones. The first one is reduction of aldehyde and ketone. So let's start. Reduction of aldehydes and ketones to alcohols. First is we are going to reduce aldehydes and ketones to alcohols. Right now, aldehydes and ketones can be reduced to alcohols with hydrogen and nickel or platinum catalyst. Aldehydes give primary alcohols and ketones give secondary alcohols. Let's write down the reactions. First, I will write the general reaction, right? I will write the general reaction. Let us suppose we have an aldehyde attached with an alkyl group like this, right? Now there is hydrogen in presence of nickel or platinum. Now for future reference, let me just tell you that if nickel and platinum are present in any reaction, if nickel and platinum are present in any reaction with hydrogen, then this means that reduction will take place. And if platinum and nickel are present with oxygen, then it means that oxidation will take place, right? So remember these two things. Now this is our case of reduction. So when an aldehyde is treated with H2 in presence of nickel and platinum catalyst, what you are going to get is primary alcohol, 1 degree alcohol, right? Now let's take the example of ketone. Plus hydrogen in presence of nickel or platinum catalyst. Now what will happen in this case? You will get a secondary alcohol, right? And this carbon will have an hydrogen, right? So this will give you secondary alcohol, 2 degree alcohol. Just remember these two reactions. These two reactions are very much simple reactions. Just remember, if you can't remember these things, there are so many reactions you can't remember that, but you can remember that if nickel or platinum is present, with hydrogen, that it simply means reduction is going to take place, and reduction means these groups will be converted to some lower functional group. So aldehyde will be converted to alcohol. If oxidation is occurring, then aldehyde will be converted to carboxylic acid, right? That's how it goes. So in this case, ketone will be converted to secondary alcohol and aldehyde will be converted to primary alcohol, right? So this was our first reaction. Now also you can achieve the same result from aldehyde and ketone. Let me write the reaction also. Simple aldehyde, this is our acetaldehyde. When treated with lithium aluminum hydride or sodium borohydride, this also gives reduction and will give you alcohol, primary alcohol. And if ketone is there, you will get secondary alcohol, right? That's how these kind of reaction takes place, right? Now these two are the reagents. In simple terms, these are reducing agents. They will reduce aldehydes and ketones to primary and secondary alcohol. So remember this also. You cannot remember all the reactions, but you can remember the reagents, because their function will not change easily until and unless some other substance is present with them. So if only lithium aluminum hydride and sodium borohydride are there in the reaction will definitely give you primary and secondary alcohol. And similarly, in the previous case, if nickel and platinum are present with hydrogen, it will also reduce the initial substance. That is our aldehyde and ketone in this case. Now let's move. Now our second reduction reaction is reduction to pinnacles. Ketones, when reduced in neutral or alkaline medium, we are talking about ketones only. We are not talking about aldehydes. Ketones, when reduced in neutral or alkaline medium, they form pinnacles. What are pinnacles? Symmetrical 1,2 diols. What are symmetrical 1,2 diols? We will write down the structure in the reaction. So wait for it. Example, acetone undergo reduction with magnesium amalgam to form 2,3-dimethyl butane 2,3 diol. What is amalgam? Amalgam is used for Hg, right? Mercury. Now let us write the reaction. We have this is our acetone, right? When treated with hydrogen in presence of Mg, magnesium and mercury, and also water, you will get, what you are going to get is CH3. Let me change the diagram for this acetone. You can write it as CH3C CH3 double bond O. Now you break the bond, you combine. There are two acetones, right? There are two acetones, so they combine together with each other and they give you this structure. What is this? This is your 2,3 dimethyl 2,3-dimethyl butane 2,3 diol, right? This is your final product. These are known as pinnacles, right? Symmetrical 1,2 diols. Why this is symmetric? Because if you cut this in half, sorry, let me change the color. If you cut this in half, both sides are kind of mirror image to one another. So this is a symmetric molecule, right? So that's what happens when you reduce ketones, you will get pinnacles, right? The medium is alkaline, basic medium, right? There are simple conditions that you should remember. Now there is a simple note. Aldehydes do not give this reaction. Remember this, aldehyde will not give you symmetrical 1,2 diols, right? So this was the second reaction for reduction. Now in reduction there are other reactions also, like Clemmensen reduction, Wolff-Kishner reduction. These are the named reaction. We will discuss them separately in the upcoming videos, so please wait for that. Now move to the oxidation of aldehydes and ketones. We have already talked about the reduction reactions, and we will talk about oxidation of aldehydes and ketones. So the first one, oxidation of aldehydes. Aldehyde can be oxidized with sodium or potassium dichromate. What is this sodium and potassium dichromate? K2Cr2O7 or Na2Cr2O7 in acidic medium to form carboxylic acid. Before we go any further, let me tell you that when you oxidize alcohol, you will get aldehyde or ketone, right? When you oxidize these two, aldehyde and ketone, you will get carboxylic acid. That's how it works. And if you reduce, this is oxidation, this is oxidation. And if you reduce, you will get, if you reduce COH, you will get aldehyde or ketone. And if you reduce aldehyde and ketone, you will get alcohol. We've already seen how to reduce aldehyde and ketone to alcohol. That's how this process goes, right? So remember this sequence. You can go from alcohol to aldehyde or ketone, or you can go directly to carboxylic acid using some reaction. Similarly, you can go from carboxylic acid to aldehyde and ketone, or you can directly reach alcohol, right? Now let me rub it. Let me pause the video and then rub it. Now let's just write the reactions. This is our aldehyde. This is our general reaction. When aldehyde is treated with sodium carbonate or sodium dichromate or potassium dichromate, you will get alcohol like this. This is 1 degree alcohol, right? No, this is reduction. You have to oxidize this. Oxidation. In oxidation, you will not get alcohol. You will get carboxylic acid. Double bond OH, carboxylic acid. Just remember, this is oxidation, not reduction. Similarly, this is first example of acetaldehyde. Acetaldehyde, when treated with sodium dichromate, we get carboxylic acid. CH3, C, double bond O, OH. This is your acetic acid. That's how you convert aldehyde to carboxylic acid, or you oxidize aldehyde to carboxylic acid, right? Now let's move to the next. This was oxidation of aldehyde. Now we will go for oxidation of ketones. Ketones can be oxidized by strong oxidizing agents. E will be there. Agents like alkaline KMnO4 or hot concentrated HNO3 to form carboxylic acid with less carbon atoms than the original ketone. This is because ketone is broken into two fragments by attack on either side of the carbonyl group. Now this is the difference between aldehyde and ketone. In aldehyde, number of carbons remains the same, but in ketones, number of carbon is reduced by 1. Right? Now the reagents are also different for ketones. In ketone, you are going to use KMnO4 or HNO3. Right? Nitric acid and potassium permanganate. Right? Now let's write the reaction. Let me pause the video. So now this is our general reaction. So what's going to happen is, when ketone is treated with HNO3, either of these bonds can break. There are two bonds between the carbon atoms. One of these two bonds will break, and then you will get two different carboxylic acids. Now if the groups are same, then also you will get two different carboxylic acid, and your final product will be like this. It doesn't matter if the carbonyl group goes with this R or this R, or this alkyl group or this alkyl group. In both the cases, you will got to receive a carboxylic acid in the end, right? So you will get two carboxylic acid when you treat any ketone with KMnO4 or HNO3. Let's take another example. Now this is your ketone, this is your 2-butanone. Now let's break the bond and treat it with HNO3. You look at the answers. You will get CH3, CH2 and C double bond O, OH. This is your first product. You will get propanoic acid. Plus the second, look at the second product, CH3, C double bond O, OH. Right? So that's how you reach the product. All right. Sorry, and the second product will be acetic acid. Now if you look closely, you have how many carbon atoms? 1, 2, 3, and in this acetic acid you have 2 carbon atoms. Now look at the parent chain, 1, 2, 3 and 4. There are 4 carbon atoms in the parent molecule and 3 and 2 in the products. So the number of carbon atoms get reduced in case of aldehydes, sorry, in case of ketones. Look at the statement. Sorry, this is oxidation of aldehyde. I have to bring it up. Look at the statement. Ketones are oxidized by strong oxidizing agent like KMnO4 or concentrated HNO3 to form carboxylic acid with less carbon atoms than the original ketone. So the original ketone, you have 4 carbon atoms, right? In the original ketone, you have 4 carbon atoms, and in the product side, you have 3 and 2, which are less than the original ketone. So that is the oxidation of ketones, right? I hope I made you understand the oxidation of aldehyde and ketone as well as reduction of aldehyde and ketone. There are a few reactions which are named reactions. We will discuss them separately in this particular topic only, that is aldehydes and ketones oxidation reduction. We will also discuss tolerance reagent and Fehling solution in the upcoming videos. So please wait. This will be it for today's video. Thank you very much for watching.